Hello, welcome back. Once we understand the concept of exception level, another important practice is to learn about how the exception level can be used by looking at the system architecture diagram. So we're going to take a look at the system architecture diagram where only one operating system runs. So if you refer to the ARM reference manual, you're going to notice those kinds of diagram. That this indicate how exception level can be used in the system. As you can see, there are two operating systems that can be managed by the hypervisor. And here is another diagram that indicate about the operating mode in ARM version and 7 architecture. But actually, the most of the system architecture is based on the two options. First option is based on the requirement that only one operating system can be running, and another option is that there is the hypervisor that manages the multiple operating system. So now let's look at each component where only one single operating system runs. Now let's look at the important part. Here, I believe that you are familiar with this kind of terminology. That is exception level 0, exception level 1, exception level 2, and exception level 3. Then exception level 3 has the highest privilege level, and the exception level 0 has the lowest privilege level. And another terminology is non-secure and secure. These are utilized in the trust zone technology. So normal application and normal software can be executable at non-secure, and the security sensitive application, more security sensitive kernel can be running in the secure. Those the non-secure and secure terminology can be identified if you take a look at the trust zone feature. But as you can see, in this architecture diagram, there's no hypervisor because the implementing hypervisor is optional. In some projects, sometimes your project does not need hypervisor. Under this requirement, the exception level 2 cannot be used. Only exception level 0, exception level 1, and exception level 3 can be used. So please remember that many of the project may not use the exception level 2 where hypervisor runs. So implementing hypervisor is not mandatory, it's optional depending on the feature of your project. Now let's look at the important part of this architecture diagram. As you know, there's only one operating system. So in the non-secure Linux operating system runs. Linux kernel runs at exception level 1, and usual application runs exception level 0. Then no hypervisor is available in this architecture diagram. Then secure software runs in secure. And normally, most of the software is running in the non-secure, but in some cases, security-sensitive application with security-sensitive data, such as password, can be handled in the particular use case. In this case, such software can be running in the secure. For this operation, we have to run the SMC instruction at exception level 1. After that, the control is move to the secure from non-secure. And the security application complete this task, and then the same SMC instruction can be performed at exception level 1 in the secure. So after that, it move back to the exception level 1 in the non-secure. For more information, you can refer to the reference manual about the trust zone feature. Now let's analyze this architecture diagram from exception level point of view. So if you trace the execution of the software, you're going to notice that The software is usually running at exception level 0 and exception level 1 in the non-secure world. So exception level 0 is interacting with the exception level 1 by running the as-with assembly instruction. If the exception happens, it moves the control to exception level 1 from exception level 0. So you can assume that in most cases, most of the software is running at exception level 0 and exception level 1 in the non-secure world. And sometimes your application should be executed under a security sensitive environment. In this case, you need to run SMC assembly instruction. And in this case, the exception level can be switched from ER1 to ER3. And then the control is moved to the ER1 in the secure world. This kind of operation may happen and during the runtime if the security sensitive data should be handled in the secure world. And then the software complete its task in the secure world. Later on, the SM instruction again to go back to the ER1 in the non-secure world. So here, this is the basic workflow when your system is running in the single operating system. So with the viewpoint of exception level, so software is mostly is running at exception level 0 and exception level 1 in the non-secure world. Now that we look at the architecture diagram from the exception level point of view in the single operating system, next lecture we will explore another architecture diagram in the virtualization system.